Okay, we're going to talk more about absolute value functions. Okay, so remember the absolute value parent function. Okay, parent function means just the plain Jane function. The equation with nothing added, subtracted, or multiplied to it would be absolute value of x. And again, reminder of the shape of the graph. They're all going to be a V shape. Again, could be up, down, moved left, right, wider or skinnier based on if it has transformations. But your plain Jane parent function, nothing else added to it, is going to be a piecewise function of two linear graphs. So a combination of your y equals positive x when x is greater than 0, and the other side would be when y equals negative x when x is less than 0, which gets you your V shape. Okay, so again, this is your parent function called plain Jane, what I call plain Jane function. Parent function, basic shape. Okay, now what if I don't have plain Jane? What if I have different transformations to that graph? Okay, if I have something added or subtracted on the inside you think opposite. Okay, so if it's a minus h, you're actually moving to the right that many units. If it's an addition, if it's adding h, you're going to move to the left that number of units. Okay, so inside, think opposite. Write that on there, think opposite. Okay, if you have something added or subtracting on the outside of the absolute value symbol, you don't think opposite. So a plus k is going to move up, a minus k is going to move the graph down. What about multiplying? Okay, so adding, subtracting deals with left, right if it's inside, up or down if it's outside. What about if it's multiplied? If it's multiplied on the outside, that is going to be a vertical, a stretch, or a compression. Okay, so if a is greater than 1, that is going to be a vertical stretch. That's going to be a vertical stretch. And think about when you vertically stretch yourself. Okay, if you vertically stretch, you're going to get taller, which means you're going to get skinnier. And if a is between 0 and 1, a is between 0 and 1, so a fraction, a half, a third, 2/3, and so forth, that would be a vertical, compression. So vertical compression. Okay, and think about it, if you vertically compress yourself, you are pushing down on your head, you're getting shorter, which means you're getting wider, okay? So a vertical compression is the same thing as a horizontal stretch, okay? So you're going to get a wider graph, okay? You're stretching your horizontal, but you're making your vertices smaller, okay? So that is a refresher of your parent function, absolute value, and then some of your different transformation rules. So let's do a couple practices. Again, the goal in Algebra 2 is to turn that brain into a graphing calculator, seeing if we can visualize what that graph looks like without the calculator. Of course, if you need Desmos.com online graphing calculator, it is fine for you to utilize that as well. So if we look at the first one, what if we have f of x equals to absolute value x minus 1 and then a plus 3. So here I'm going to start with the inside. if I have inside -1, I'm going to have inside think opposite. That means that it's going to be moving right 1. If I have +3 on the outside, that means we're going to be moving up 3. And the 2 here on the outside being multiplied, again, it's 2 is greater than 1, so it is a vertical stretch. Okay, again, a vertical stretch is going to make you taller, skinnier. So you're going to have a skinnier graph. Okay, so some key attributes of this absolute value. Again, vertex. Vertex is opposite the inside. So if I'm moving -1, that's really right 1, so +1. And the number on the outside, so vertex is 1, 3. And we could sketch a quick graph again, or you can use Desmos online graphing calculator by simply stating that vertex is going to be at 1, 3. And a vertical stretch of 2 means I'm going up 2 to the right 1 to get to my next point, up 2 to the left 1 to get to my next point, and notice I'm going to have a much skinnier graph, okay? Because again, to vertically stretch, think about pulling up on your head. You're going to get taller, taller, skinnier, which means that you're horizontally compressing. Do one more of that nature. So let's say that we have f of x equals absolute value x minus 8 minus 2. So let's start with the inside. Inside, think opposite. So you're leaving left or right, think opposite. So a -8 is actually moving it right 8. And a -2 is actually moving it down 2. So where would our vertex be? Well, our vertex is opposite the inside, so +8, and the outside number, -2. Again, vertex is the top or the bottom of the graph. And if we wanted to draw a quick sketch, we have a vertex at +8 and -2. And it's not wider or skinnier, so think of it as like a slope of 1. So your linear component is a slope of 1, and it's upward because we do not have a negative in the front, okay? A negative would be a reflection over the x-axis. So let's work with a different type of problem. What if we're given a function f of x equals 2 absolute value x plus 6 minus 4. And we're looking to find for what values is f of x equal to 6. What values is f of x equal to 6? Well, when you look at the problem like this, okay, f of x is just fancy for y. So really here, y equals 6. So we really have the equation y equals 2 absolute value x plus 6 minus 4. And we can plug in the y value of 6. So y equals 6. So now we're just going to isolate the x, okay? Our goal here is to isolate the x. First we're going to isolate the absolute value. So how am I going to isolate the absolute value? I need to add 4 to both sides. 6 plus 4 is 10. Then I have 2 times the absolute value, so I need to undo the multiplying by 2, so that is dividing. So now that we've isolated the absolute value, we've moved to the other side everything that's on the outside, adding, subtracting, or dividing by doing inverse operations. We are now going to, we now have 2 options here. So what is absolute value? Okay, absolute value means that everything inside are x plus 6. My bad. So that means that everything inside x plus 6 could equal positive 5, or since absolute value makes everything positive, x plus 6 could also equal a negative 5. Because if it equals a negative 5, well, then we would take absolute value to become positive either. So we have to set up 2 equations, okay? So we have to set up 2 equations. So split into 2 equations. So we're actually going to have 2 answers for here, okay? So everything, after you isolate, everything inside equals positive. The other side, everything inside could equal negative that. So now we're just going to solve for x. So we could subtract 6 from both sides. So x would equal negative 1. We can subtract 6 from both sides here. X would equal negative 11. And before we box our answers, we should always check. Okay, so I'm going to come over here and check. Well, what do we mean by check? Check means I'm going to go back to the original problem and plug in my x value to make sure that I get the corresponding y value, okay? So my beginning problem is that 6 has to equal to absolute value x plus 6 minus 4. So let's see if that rings true for both. So let's start with the left-hand side. So 6 equals to absolute value. We're first going to plug in negative 1. So negative 1 plus 6 is 5. Absolute value of 5 is just 5. 2 times 5 is indeed 10. 10 minus 4 is 6. So yes, it checks. I can box negative 1. So let's do the same thing for negative 11. So if we check negative 11, we're going to have 6 equals 2, absolute value. We're going to plug in negative 11. And let's simplify. So negative 11 plus 6 is negative 5 this time. Absolute value, again, would be positive 5. 5 times 2 is 10. Minus 4 is going to be 6. Does 6 equal 6? Yes, it does. So we can box it. Okay, so when solving absolute value equations, steps, isolate the absolute value, move everything over using inverse operations, and then you have to split into 2 equations. Everything inside equals positive, everything inside equals negative. Everything inside equals negative, and then check your answers. So let's try one more of that nature. So what if we have f of x equals negative 5, x plus 1 plus 3. So find x if f of x equals negative 12. So again, f of x is just fancy for y. F of x is fancy for y. So we're going to plug in that for y. So 12 equals negative 5, absolute value, x plus 1 plus 3. And let's isolate the absolute value. So first step is to isolate the absolute value. So if we isolate the absolute value, we first need to move the 3 over. Oh, and this should actually be negative 12, my bad. Negative 12. So actually, we need to back that up. If that's negative 12 minus 3 is actually a negative 15. So divide by negative 5, and we get 3 equals absolute value x plus 1. And now we're going to split into two equations. Everything inside x plus 1 could equal a positive 3, or everything inside x plus 1 could equal negative 3. Now we're just going to solve for x. So if we solve for x, subtract 1. Subtract 1 from all sides. So x here would equal 2, and x here would equal negative 4. But before we're done, we're going to make sure to check our answers. So if we check, we go back to our original problem. Negative 12 equals negative 5, absolute value. We're going to plug in 2 plus 1 plus 3. So let's see, we have 2 plus 1. 2 plus 1 is 3. Absolute value of 3 is 3. Negative 5 times 3 is negative 15. Negative 15 plus 3 is negative 12. So left side checks. I can box my answer. And let's do the same thing for the right hand side. Negative 12 needs to equal negative 5, absolute value. This time we're going to plug in negative 4. So negative 4 plus 1 is negative 3 this time. Absolute value is going to be positive 3. Negative 5 times 3 is negative 15 plus 3. And we get negative 12 equals negative 12. Checks. Box our answer. So for this problem, x has, again, two answers. X equals 2 and x equals negative